All right, so we've discussed the second law of thermodynamics before. We discussed the fact that when you have a machine, you can never get 100% of what you put into it back out. There's always some loss to the surroundings. Okay, this is true in biological energy conversions as well, which is what digestion and assimilation and all the things that your body does are. Although there's thousands, perhaps even millions of different things of these kinds of interactions that go on in your body at any given time. So there's a lot of opportunities, a lot of chances for inefficiency, if you will. Although I hate to describe it, nature as inefficient, but it's, yeah. But what happens, anyway, the way things balance out is that about 10% of the energy and the biomass of your food is packed to the next. I'm going to go ahead and give you this group one, but let's be more specific. The next trophic level. I know I didn't have two spaces, so you know, whatever. That's my mistake. Okay. So next trophic level. So from producers to consumers. So for example, if you have a patch of grass that the cow is grazing on, okay? A cow, yeah, bovine animal. And that patch of grass has absorbed 1,000 calories of energy from the sun and has absorbed a kilogram of carbon dioxide, water, and other nutrients to make the molecules that grass is made out of. When that cow eats that grass, it'll only be able to use about 100 calories of energy, or 10%, from that grass. It'll only get that much. And the building blocks it gets from it will only be from a kilogram of biomass. It'll only get about 100 grams of that to incorporate into its body. Now this is an average. As you might imagine, this varies greatly from species to species, interaction to interaction. But the overall average that ecologists have observed is about a 10% exchange from one level to another. So this has a very high impact on the structure or the number of different types of organisms that you see in your basic ecosystem. By virtue of the fact that you're only going to be able to transfer about 10%, you're going to need 10 times as much food as the mass of the organism above it. In other words, you're going to have 10 times as many secondary consumers as tertiary consumers, or no more than 10 times, I should say. And this is by the way, this is by mass, okay? So, you know, one cow is the equivalent of thousands of mice, for example, but both of them are primary consumers. So this goes by biomass. And then 10 times as many primary consumers as there are secondary, and 10 times as many producers as primary consumers. So hopefully you guys got that figured out. That looks like you did figure out that notation there, those being the different levels on the food chain. Okay. And you can see that if you go into an ecosystem, let's say you wander around through the forest, Mats, what are you going to see wandering around the forest? What's the main thing you're going to see in that forest? It's the reason why they call it a forest. Trees, right? Forests, yes. Trees. You walk around to the grassland, what's the main thing you're going to see? Grass, right. As a matter of fact, most ecosystems are named by the main producer that you find there. That's what you're going to see a lot of. That's what it has to be. Let's say your average forest in Florida, after you stop seeing the trees and the palmettos and all that, what's the next thing you might see as far as animals go? What? What do you see? Walking around the woods around here. You see about here, yeah, squirrels, right? It's the main thing you see. What kind of consumer are they? Primary, secondary, tertiary? Yeah, primary, yes. Unless you see squirrels munching on a rat or something, or a snake, they are primary consumers. They're primarily herbivores. They may eat the occasional bug or something, I don't know, but so they're prevalent because they have plenty of food because they're primary consumers. And then if you get lucky, you might see a snake, or you might see a hawk or something like that, and that would be a secondary or tertiary consumer from there. So that shows you why in pretty much all ecosystems you're going to have a lot of producers, followed by about 10th as many by weight primary consumers, and so on up the food chain. Okay. Now, one of the things that happens, one of the ways in which this, we call that an ecological pyramid, by the way. And one of the things that happens because of this is that toxins have a tendency to build up as you go up the food chain. Things like pesticides that are persistent pesticides, and this whole process is actually why we got away and banned a lot of these persistent pesticides. That and the fact that they were showing up in environments much further away from where they were applied. And things like heavy metals too. Of course, these elements are not going to be broken down and become something else. They're always going to be an issue in the environment. And so they are not going to follow this 10% rule because they're not being metabolized. They're not being broken down for energy. They're not being used as building blocks. What your body and the body of most organisms, most vertebrate organisms does when it encounters these things is it tries to keep it from traveling the rest of the way through your system. Your liver is the main thing that does this. And it'll actually store it away, shunt it away in fat tissues. That's the main place it goes. And the reason for that, fat tissues do not have a lot of blood flow. They do not have, it's a storage, so they're not very vascular. Things that are in there can be kept away from other things. And let me go ahead and fill in the blanks here. This is known as bioaccumulation. All right, and then toxins pass through the food chain without decreasing because of that. So instead of, you guys need to sit tight, seniors. Sorry, I'm not going until I finish this. So they keep out in the same amount, and therefore, when you get up to the upper levels, you have the highest concentrations in your upper level predators. Highest concentrations, that says there. Sorry, I'm not sure what I put down there at the end. This is known as biomagnification. Biomagnification. Okay. First noticed in bald eagles, birds of prey that were populations were declining, yet they're not typically hunted and they're away from toxic sources. Any questions?
No.
All right, that's it. Seniors, you can go.